In the late 1980s and early 1990s, the United States Air Force faced two insistent challenges. First, next-generation Soviet aircraft like the MiG-29 Fulcrum and Su-27 Flanker had introduced a new level of maneuverability and performance. Second, emerging surface-to-air threats like the S-300 and S-400 SAM systems were becoming increasingly lethal. The result? A looming concern that the USAF might soon rival, but not surpass, a new class of challengers. As such, an aircraft was required not just to match, but to surpass stealthy, fast, agile, precise, and Insert clips of the Advanced Tactical Fighter ATF program, concept sketches of YF-22 and YF-23. Narrator. In 1986, the U.S. Department of Defense launched the Advanced Tactical Fighter ATF program, aimed at leaps in stealth technology, avionics, supercruise, and sensor integration. By 1991, two prototype aircraft competed: the Northrop McDonnell Douglas YF-23 Black Widow II, sleek and elusive, and the Lockheed Boeing General Dynamics YF-20, too powerful, agile, versatile. In 1993, after intense competition focused not just on raw performance but also logistics, supplier integration, and future adaptability, the USAF selected the YF-22 as the winner. 3. Genesis and early development estimated word count, approximately 600 seen, Lockheed Skunk Works hangar, engineers studying prototypes. Narrator. Transitioning from a prototype to an operational aircraft took years of rigorous development, testing, and evaluation. Lockheed Martin, joined by Boeing and General Dynamics, refined the design, ironing out issues in stealth retention, flight control, maintenance access, and structural durability. Cut 2. Wind tunnel tests, computer modeling, stealth coding, application lab. Narrator. Stealth geometry underwent countless iterations in wind tunnel and full-scale stealth labs. A lightning-quick turn in radar cross-section and infrared signature was essential, not just in visibility from the front, but survival from side, rear, and overhead perspectives. Engineers also invested heavily in RAM radar absorbent material that could withstand environmental exposure and sustain combat readiness. Footage of captive carry F-22 on B-52 or under C-54 arrival overseas. Narrator. To project reach, demonstration aircraft were ferried globally. Nations took notice. India, Poland, and Japan began reconsidering their procurement strategies, alerted to the new standard that would shape future air power for decades. 4. Technical breakdown, airframe, and stealth estimated word count, approximately 700 interior shot begins inside hangar, highlighting EF-22's design. Narrator. At its heart, the Raptor's airframe is a masterpiece of stealth design. From the jagged edges of its intake ramps to the sawtooth trailing edges of its control surfaces, every surface scatters radar waves away from hostile sensors. Built around a monolithic titanium and composite structure, the airframe provides the strength to endure high-G maneuvers at supersonic speeds, while shielding critical systems from radar detection. Cut 2. CGI overlay, indicating internal fuel tanks and stealth fairings. Narrator. Even the internal layout was optimized. Weapons bays concealed under stealth covers, titanium fuel tanks with internal tanks providing symmetry and low absorption, and internal bay doors that open with calculated precision. Cut 2. Drops of fuel pooled under a jet infrared suppression emphasis. Narrator. Infrared signature reduction was also critical. The F-22's Tiger Stripes exhaust design, combining chevrons and mixing techniques, ensures hot engine gases are diffused and cooled prior to emission. This greatly diminishes the Raptor's heat signature, making it more difficult to detect with infrared seekers. 5. Engines and Supercruise estimated word count, approximately 500 seen engines in operation on a test stand. Narrator. The F-22 is powered by twin Pratt & Whitney F119PW100 turbofan engines, each capable of around 35,000 lb thrust. But more than raw power, it's how that power is used that distinguishes the Raptor. Overlay animation, airflow paths, Supercruise demonstration. Narrator. Allies wondered, can it cruise at supersonic speeds without afterburners? The answer: yes. This Supercruise capability allows the jet to stay above Mach 1.5 for long durations. That means faster engagement timelines, lower radar emissions, and less heat. Achieving Supercruise involved integrating low bypass engines, highly advanced inlet design, and a refined nozzle flow geometry. Pilot footage in cockpit during Supercruise flight. Pilot voiceover. Supercruise changes how you fly combat missions. You're always on the clock. You're always first on target, on station, and that gives a tremendous psychological and tactical advantage. 6. Avionics and sensor fusion estimated word count, approximately 60 overlay, CG overlay, cockpit displays, Data streams, integrated sensor feeds. Narrator, perhaps the cockpit's crown jewel, is its sensor fusion architecture, a consolidated data stream from every sensor, radar, IRST, infrared search and track, electronic warfare, and Link 16 data links. All of this fuses into a predictive, real-time battlefield map. Pilots need only to input a desired action, like engage, target, Bravo 2, and the system displays optimal weapons, range, track, history, friend, foe identity, and threat assessments. Interview frame. Test pilot near cockpit. Test pilot, you look at one screen, one pop-up, not 5 separate ones. That reduces cockpit workload and improves situational awareness exponentially. Visual, an APG-77 radar display in action. Narrator, the radar at the heart of this system is the Northrop Grumman, an APG-77 AESA, with active electronically scanned array technology. It can switch modes faster than the blink of an eye. Tracking, jamming, targeting all, without mechanical movement. Overlay video, Raptor launching both AIM-120 AMRAAM and AIM-9 Sidewinder. Narrator, with far superior range detection and networked targeting, the Raptor can engage multiple hostile aircraft or ground mobile targets long before they know it's a threat. It often spills out AIM-120 DAM RAAMs or AIM-9X Sidewinders, each fired from internal bays to preserve stealth until release. 7. Weapons bays and loadout flexibility. Estimated word count, approximately 400 cut to slow motion footage of weapons bay doors, opening mid-flight, missiles ejecting. Narrator, one of the defining traits of the F-22 is its internal weapons carriage. Designed around stealth, the Raptor houses a standard load of 6 AIM-120 AMRAAM air-to-air missiles in twin rotary launchers in the mid-fuselage, bays 2 AIM-9 Sidewinder, short-range air-to-air missiles in side bays, and M61A2 Vulcan 20mm cannon for close-range defense. Overlay graphic, alternate air-to-surface load configurations. Narrator, though optimized for air superiority, the Raptor can carry JDAM or SDB bombs on 4 wing-mounted stations when stealth is de-emphasized. These weapons are carried externalist. Missions sacrifice stealth for precision strike rolls. 8. Maneuverability and performance. Estimated word count, approximately 500 dynamic footage. The Raptor climbing, rolling, and executing high-alpha maneuvers. Narrator, with thrust vectoring nozzles that swivel, yaw, and pitch, combined with an advanced fly-by-wire flight control system. The Raptor can execute pinpoint, agile, and high-alpha maneuvers near vertical climbs, pitch-back turns, and instantaneous changes in vector that leave adversaries guessing. Pilot interview inside cockpit. F-22 pilot, the Raptor just doesn't fly like other jets. You initiate a command and it snaps. Reaction is instant. You can do things in an F-22 that other aircraft can't attempt without risking a departure. Overlay, chart, thrust to weight, and turn rate comparisons versus F-15, F-16, Su-27. Narrator, in combat evaluations, the Raptor outperformed legacy fighters Avon, Russia's most capable and multi-role platforms. Its sustained turn rate and combined power-to-weight ratios have been confirmed to be leaked. Hopping 9. Operations and deployment history, estimated word count, approximately 600. Clips plane arriving at Al Udeid B, Qatar. Pilots prepping for sorties. Narrator, although forced into early retirement under sequestration pressures, the Raptor has served in several key operations. In 2007, it was first deployed to Kadena Ab, Japan, sending a clear signal to potential adversaries. Overlay, date stamps. Scenes from exercise, Red Flag, Operation Inherent Resolve. Narrator, it participated in exercise Red Flag over Nevada, integrated with F-15s, B-2 South, E-3 AWACS, and F-16CS. In 2014, Raptors supported Operation Inherent Resolve, flying combat air patrols over Syria and Iraq, successfully engaging targets, including mobile SAM radars, and conducting ISR missions to aid coalition forces on the ground. Pilot on board, discussing performance in Middle East heat. F-22 pilot voiceover, in desert environments. We still maintain our stealth signature. That's a testament to how resilient the materials and cooling systems are. Map overlay. Strategic F-22 bases. Langley, Honolulu, Elmendorf, Kadena. Narrator, back home. F-22 wings are stationed at Langley AFB, Virginia. Joint base, Elmendorf, Richardson, Alaska, Kadena Ab, Japan. And Hickam, AFB, Hawaii, providing global reach and quick response capability. 10. Maintenance, support, and cost. Estimated word count, approximately 400 footage. Ground crews swabbing inlet surfaces, applying ram patches, refueling, Narrator, low observability comes with costs both financial and logistical. The Raptor requires extensive maintenance, stealth coatings that must be carefully maintained, sophisticated diagnostics, and unique support systems. Each aircraft can demand hundreds of man-hours per flight hour to remain competitive. Graphic, production cost versus maintenance cost breakdown. Narrator, originally projected at around $33 million per aircraft in $1,997.